All right, happy Friday. Happy PA3 is done day. So, any lingering questions on PA3? All worked out? Okay, good. All right, questions on PA4? Insert function, okay, just in general?
Yeah.
Okay, let's talk about inserting into a tree. So there's the algorithm, first of all. Whatever your tree looks like. You want to insert a node into here. We know the high level view of what we want to do. We want to start at the root and we want to move left or right until we get down to a leaf node. Okay, so let's say we want to insert some particular number n. We can only insert at a leaf. We're going to start at the root. We're going to look to either the left or the right, depending on whether this is bigger or smaller than the root. Because our guiding principle is everything's got to be bigger than the root if it's on the right, smaller on the left. So we're just going to move down and we're going to go left and right until we get to a leaf node, and then we're going to put our new node on either the left or the right. Okay, that's the paper and pencil version of what we're going to do, but what we're going to actually use is recursion. Okay, so we're going to simplify the process of inserting as follows. Two cases. One, if the tree is empty, then we're just going to return a tree containing a single node. All right, that's how you insert into an empty tree. Just make a node. That's the root of the new tree. Okay, otherwise, since the tree is not empty, we're going to insert n into the left or right subtree. In other words, we know we're going to insert our node either into this subtree or into that subtree. We're not going to replace the root, right? So it's got to go into one of these. How do we know which one? See if n's bigger or smaller than the root. If n is bigger than the root, we're going to be inserting n somewhere into this. If n's smaller than the root, we're going to insert n somewhere into that. And how do we insert into one of those trees? We're going to use our insert function, which is what we're writing. Okay, that's the whole recursion thing. So if the tree is empty, we just return an empty node. Otherwise, if n is bigger than the root data, insert into root right the number n. Else, insert the number n into root left. So in this case, where n was some number smaller than the root, we're going to say if n's bigger than the root, do this. It's not, so we're going to say take root left, that's this tree here, and we're going to say insert n into that. And what insert's going to do is it's going to move down there, and eventually it's going to come down here, tack an n onto here, stick it as the right child. And then we got to do one more thing. We've got to make sure that whatever insert returns to us, which is the root of the tree that it just updated, we've got to make sure that's what we're pointing to on the left. So we're going to want to say root left equals insert. Or in the former case, root right equals insert. And this business of root right equals root left equals, that only comes up one time. It's kind of an edge case. We're suppose this is our tree, so this is root. And we say insert a 5. Well, okay, let's do it officially. Insert root comma 5. And we've seen this code when we were playing with these recursive worksheets. So I'm going to pull this code out. All right, so here's our insert code. If our number is bigger than the root, root right equals insert, otherwise root left equals insert. Okay, so we're trying to insert a 5 into the tree that consists of just a single node. All right, the tree is not empty, so we can't just return a node containing a 5. So we're going to say basically if 5 is less than 10, and it is, so we're going to say insert root left. In other words, put 5 into the left subtree. Well, what is the left subtree of the root? It's null, right? So this is really saying insert a 5 into a null tree. And if that's all we do, right, when we're done, our root still looks like it's just a single node 10. Right, this is going to return a tree containing one node, which is a 5. The only way that becomes part of this tree is if we say root left equals whatever insert returns. So now our root was 10, the left child is going to be what insert returns, which is a 5. Now we're building a tree. Any other case, right, this is going to return exactly what we passed it. If we pass it, a node containing 7, it's going to return that same node containing 7. And this is just saying x equals x, right? It doesn't do anything. But in the one case where we're passing it a null tree, we've got to take what it returns and stick that on the left or the right of our root. And in fact, that happens every time you insert when you recurse down to a leaf node.
So return that means return the new node.
Mm-hmm. Yeah, so in here we always return the root of the tree that we were given, right? The interesting case is if the root was null, we created a new node, we set its data value to our number, and then we returned that new node instead of just returning the old root, which was null, right? But that's what actually makes the recursion work. And there's always some line of code that looks totally optional in recursive functions that actually is the one that makes everything happen. It's a little weird that way. It's like the Whoville thing. All right, so does that make more sense? Okay. And then deletion's the same thing, right? Because if you delete a node and it happens to be the node on your left, you've got to replace what you deleted with the root of what was in the subtree. So when we delete, it's always going to be root equals delete root comma number. All right, other questions? All right, let me turn on some lights. Let's play around with tree balancing. So I want you to find some people to work with. Find a spot on the board with some markers. I'm going to leave these up here. Grab one of these for a group. And we'll start building up some trees.
I was actually going to work on ICA.
Let's get the sheet. Drink some coffee, man.
All right, so here's what we're going to do. We're going to start with an empty tree, okay? And I'm going to give you a node to insert. And what I'd like you to do is the following. One, insert the node by just starting at the root, moving your way down until you get to a leaf, putting it on the right spot. Two, calculate the balance factor. Starting with the node that you inserted and working your way back up. Okay, so you're going to calculate the balance factor. So find the height of the left and the right and subtract. Okay, I'll turn this off for a second. So insert the node into a tree, calculate the balance factor from the node you insert on up to the root. And then 3, if it's not balanced. If it's balanced, don't have to do anything. If it's not balanced, then I want you to apply a rotation. Well, identify what case you're in. So you're going to be in either left, right, right, or right, left, right, based on your balance factors. Apply rotation and redraw the tree, and then if there's a second rotation, apply the second, redraw, and then calculate balance. So you want to keep the trees around, right? Make a new copy of it to do the rotation to. When you've got that, make a third copy if you've got another rotation to do. And when you're done with that, right, we'll look at those after each of these inserts. And if that's all fine, then you can delete the other ones, but keep that latest tree. And we'll insert a new node, recalculate the balance factors, and so on. Okay, so you want to sort of organize your work so that we can see what you're doing and make sure everything's going fine. Okay, let's start off. Let's just insert a 100 into your tree. This one's not going to be terribly painful. Yeah, I'm just going to bring up some lights. All right, good. And write down the balance factor. So balance is height of the left minus the height of the right. So balance factor. So how did you get your balance factor?
Oh, you guys. Like this. Yeah. That's what you were trying to explain. Yeah.
All right, so we started with 100. Go ahead and insert 200.
Yeah, she writes that one. I understood. Like sometimes your brain doesn't work.
That's how physics teaches.
We're inserting 200.
They assume that you
It's one jump, right? It's one one. How did it go from
Node is negative one.
So the height of this one is 1. So negative 1 minus 1 is negative.
Not yet.
That's not right. Wait. Negative 1 minus 1 equals 0. Wait, how's that right? Minus 2. How's that?
I think it was just minutes.
My brain is. Wait, how is it confusing? That's right. One jump though. Oh.
Balance factor
Oh,
for 200.
that's right.
What's the left subtree of 200?
Okay, all right.
What's the right subtree? The height of the null.
It's a hard one.
So what's minus 1?
You guys, how did you calculate it?
Minus 1 minus
Side
1.
was negative 1. Right
Yeah.
side is 1.
And how do we calculate it?
All right, what about the 100 now? What's the left subtree?
Why is the negative 1?
Okay, so that's minus 1. What's the right
Second one to be negative 2. Up 1.
No. Okay.
Yeah, right subtree has a height of 0.
Left side.
I remember it confusing all the numbers out there are zeros, aren't they?
Yeah,
That's right, they did negative 1 and 0.
that's the height of the left
I'm pretty confident it's 0,
subtree.
but I'm not really sure about this one.
This
Because
is negative 1, which is 0.
yeah.
And this is negative 1
Someone did.
I mean,
Minus 1 minus 2.
The height of that tree.
You're calling this negative 2 or this is.
Oh, negative 2.
So this is not balanced because it's a difference of 2. It should be balanced. Negative 2 should be I probably want to ask Nick how to, because I was kind of lost when he was explaining like the balance. Oh my word, that makes sense. That's what makes sense. Okay.
What are your balance factors there?
I'm kind of grouping up with
Step 1 got 0. Negative 1 minus negative 1, 0.
So can you write the balance factor next to there?
That would be the height.
Okay, I agree with the 0. How did you get this?
Negative 1 minus negative 1.
So the height of
That's one not sure.
the height of a single node is 0.
Yeah.
The height of something like that is 1. But if it's just a single node, that's got a height of 0.
What if you just half a part?
Still a height of 1.
Negative 1.
Okay, so a quick thing to be careful of, right? When you're finding the height, you're talking about trees. Okay, height is a function of trees, depth is a function of nodes. Height of a tree is the depth of the deepest node. But it's basically start at the root, how many steps does it take to get to the node that's furthest away, that's the height. When you're finding the balance factor of a tree, right, and there's stuff over here, we're trying to find the balance factor of this node, find the height of this tree, find the height of that tree. Okay, so the height of the two subtrees of this node, that's the heights whose difference you want to take. And be really careful if your node is something like this, right? It's got children that are null. Or something like this, the left child would just be this single node. And quick reminder is the height of a null tree is -1, height of a single node is 0, height of something that looks like this is 1, and so on. Okay, so I think you're good with balance factors so far. Go ahead and insert a 300. So put in a 300, recalculate balance factors.
Oh, here. You remember, if flip it like this, it will become the right. This will become the left. This will become the right.
I can't do that. Why can I not do that? What
This
is
will be called
Okay, so we tried the balance by itself. Okay, so this one we have to find a height of the left subtree and the height of the right subtree.
And this
The height
will be,
is -1, -1 minus without the height is 0. Now this one has to find the height of this left subtree.
why right is 0
And
is
then
it?
height of this left subtree.
No, if you have -1 and -1,
I've just
how much -1, you will be
Oh, no, the height of this
which is 0, yeah. Yeah.
-1 minus 1. That makes sense? Yeah, now it's on balance, right? Yeah, so it doesn't need to be balance, now we switch it. Oh, okay, that makes sense. Perfect. That's still off. That's okay. Great, you know. I know you're right, okay. So it's definitely a right way
Let me make sure this is.
yeah, our color is, yeah. So now we gotta change 3 down here.
Something that you would actually like want to look at, like that. I don't have to do that because
Yeah, rotate the 4 up. So now, the balance of this one. You're right. Sorry, I you know.
And the height of the tree is 3. The balance factor though is the difference between the height of the left and the height of the right. So right now the balance factor is 0.
Like when you take the other single node.
Okay.
You see the height of a single node is 1.
0.
That's what I thought.
You still have to type it in.
Oh, what is that?
That's a tree with 3 nodes. Height of that is 1. Height of that tree is 1.
Okay.
And the height would be 2. Yep, exactly, yeah. Nope, the height of the tree is the depth of the deepest node.
Oh, you want to go through the process again?
This one I know, but this one.
You're gonna explain this one. Yeah, so
All right, I think you're good. Go ahead and insert 50. Yeah, let me borrow your eraser.
The balance of now we have so look at the subtree, the height of this one is 0, and the height of this one is -1. So 0 minus -1? 1. Then come on, wait. So 1 minus 0. Oh, I see. Yeah, you're switching it, but yeah, 0 minus 1.
Okay, comment.
Yeah, it should be. Oh, yeah. That's how I was confused. Why? No, it's not positive. No, it's not. There's no way. Okay, so we know it's the height the left minus the height of the right. So the height of the left.
So what's your balance factor on 200?
Why is it when switch?
I got an A.
Because we already switched it.
Yeah, what do you mean?
And this is I mean, -1,
Yeah, okay.
when you have negative 2, yeah,
One, okay, good.
that's the value of not the
Is that 2 or greater? Yeah. 1. That's how I
then the height is basically 1 to that value is basically what they call
The balance.
the balance. That's the
Okay, so the balance of this is one node right here. We're talking about this single node, and the rule is of one single node is the balance is 0 because you have a null here and a null here. And that means you have
-1 minus -1.
you add together.
Like this,
No, it's like you have something that can happen. It's not 0 or 1.
now he confused me.
Yeah, that's okay.
What do you think?
Now I understand.
Yeah, this height here from this point, you're talking about hierarchy split in 2 because you're talking about
a depth of 1 here and a depth of 2 here. The height would be the max depth.
Yeah, but right is 2 steps.
You're talking about the max depth of the entire tree, left or
But
right.
how determine advance or advance to compare how deep is the left area, how deep is the right side? Exactly.
Yes, you're gonna have to, like, you have to take it as like a formula. You can't
Compare
really.
how much it deeps the left and minus the deeps of the right. Which one is like what I did already?
Oh, you're talking about like.
All right, ready for some more rotations.
Oh, the depth.
Not the depth. Zero.
All right, so insert a 25. Yeah.
Can't figure out it first.
What am I looking at?
Insert one.
Yeah, oh, okay.
Only chicken farm.
Actually,
No.
does it matter? So if you're looking at a particular node, you just ignore it.
Both. Height of the left,
Right.
minus
Okay,
the
okay,
right.
okay.
Yeah, okay.
Yes, you're right. That's zero, yeah.
This will be, this is 1. Minus the 3, which is for the, and then that's 0 minus 0. So,
Okay, so we're looking at the height of 1 minus 0.
Really? Not this?
So then we gotta make.
You're looking at this node, right? Oh, wait a second. Wait, look, no, 1, 2. Look at this node. 1 minus 2, right?
Oh, yeah.
Because you know, 1. Oh, wait. This would be 2. This would be 2. No? Okay, so let's.
Oh, yeah.
Yeah, that'd be 2. Right?
That will be 2.
Yeah, so
This is
you're
1.
one.
Minus 1. Minus 1, which is 2. This is 2.
Oh, yes, we do.
That's why it would be not balanced. 5, and this 2
minus 0 is 2.
and this one.
Yeah.
That's the case.
So now we got a balance.
Right? Yeah,
Oh, let's talk about this node. So now we gotta move this tree down to here. Yeah.
No, I trust you. I was just saying it out loud. I'm sorry.
Yeah, we are.
No, we'll still be.
You know why? 0 minus 1.
No, 200 will still be.
Minus 1. 1 minus 1 is 2. 2 minus 0 is 2. Oh wait, that's not. That you
Yeah, okay, no, this is right.
It would be 100 in the top, 200 here.
Yeah, change that color.
100 in the top. This, 300, and the 200. I mean the 300. 200.
These guys are pretty advanced trees.
So now we can
All right, so what kind of imbalance is that?
I think so. I've never done it, so, yeah.
You're not gonna touch anything above.
It's like, well, I don't know what any of this, so I'm using.
And you got to adjust those three nodes to make all this stuff.
Oh, yeah.
Background is not what I did.
So every time you row, so take your one. Okay.
It's all the changes.
It wouldn't be ideal, like this
What matters, right? The height is this three minus.
Yeah, so your 50 is like a 4. Well, how would you do 3?
But that doesn't mean anything. That's not how it happens. Wait, what? Because,
I just think it's supposed to do that.
there's a little one too.
Yeah, you can do it.
The case was this one.
Kind of like two lines.
Like so. Going off of the main keyboard, it makes like actual program. Make sure we always allocate what you were your balance. Okay, thanks.
Same, that's what I did. That's the same thing,
Okay, so once you hit that 2, right, this is all you're going to do. You're just going to manipulate this. Okay? So it's going to stay there. That's going to stay on the right.
Yeah, I
You're
know.
going to modify this. So it's like on that.
Use it and you look at it by dividing the first one.
Yeah, just ignore that.
This is one.
Yeah.
Just mind the because they are related to each other. They have kind of like this.
Oh, yeah, I have no idea
No, actually, you'll be right. Okay, it's just not 50.
Oh, is
Yeah,
that?
I'm just kidding.
Oh my God.
Where is the this though?
All right, so let's see. You had 0, 1, and 2. So you find a balance factor. Yeah, -2, 1. Okay, so at that point, everything you do is right here. Okay, the original tree, 200 is going to stay there, 300 is going to stay there. And whatever you change this into, that's going to go to the left of 200. So all you're going to do is modify this. You're going to do that using.
We skipped
Oh,
that.
got it there.
You're supposed to go from.
Okay, so just looking at this, what cases are live? Left, right. So this says,
That's why, like,
this is node 5, 4, so if you take this and redraw it like this,
then on the other way,
it's going to look
You take just the 100 or pre-file, that would be 50, 100.
Alright, so there's the balance version of this, now you just replace this with that. Right, so you got 200 and 300 and you got all this stuff on the left. Alright, there's your balance tree.
I thought, you know what I thought in the beginning? When we find this is like this, I thought it was just like.
Okay, okay.
And if there is any child here, it's enough.
Okay, no.
But this is perfectly balanced. So what do you, well, like on the deepest that we can go, and then once we hit a height, like a 2, about a 2 factor.
Yeah, start with the nose of your insert and go up. You get the 2 or minus 2, stop there. And don't worry about it. I mean, this is a 2, but it'll get fixed when you fix this. Yeah. All right, cool. Let's insert something else. All right, insert a 150, please. 150. 150. All right, and since we're going to be out of time in 4 minutes, after the 150, you're going to want to insert a 125. So what I'm going to suggest is that before you're out of time, each person write down where you are, right? Make a copy of your tree, and then work on this at home. And or over the long weekend. And we'll pick it up on Tuesday. All right, let's try 150.
Now we have to find the balance minus
You tell me. Because
this one, it's 0.
balance factor is 0. We're not looking at balance factor.
Wait, that's oh, minus 2.
Yeah, balance factor.
And then this one.
Work with a guy named Hugh and call him Heward.
Okay.
I think he said well.
I was just thinking that, I was like, if we have to.
It should be
Oh, did we?
Oh, yeah.
We went to do a little.
Because he said start with 2 level number.
Okay.
Q or minus 2 for the balance factor. That's where.
Yeah, I just think it'll be a lot right.
Now we have to solve the,
You want to see what I'm using indexes for your flags.
okay. No, it's the height.
So what's the height of the balance factor of 50? Because
the height of this one is.
I just did like this.
0 minus 1. All right.
Where are we? We can do it. That's true, but I thought it had to be 2.
That looks good.
Then here is the
So what happened after that?
445.
Yeah, what were your balances? So it is balanced. So that's good. We can only add one at a time. So like, that's fair.
So when you declare it, you just declare it.
What? That?
If you're using it at 200, then.
So.
So this way.
That's 200, right? With a 300.
300 will just stay on the right, yeah.
Okay. So that's like.
Okay, that looks good to me.
And also, I think I did 2 of these.
You got 2 and minus 1.
Doing perpetual
that's a lot of rotation. That's gonna take 2 rotations.
You're making weird faces over there on the conference.
All right, so I will see you either in 2:15 or I'll see you on Tuesday. Have a good weekend.
Then left, right case.
I was like,
Left, right case, then you will begin by this.
Oh, really?
Look what it says.
Or like you have. I love your hair. It's so good.
Okay, take that again. My picture got blurred.
Other integers and other functions.
Okay.
So we like add them all up in the if statement. So you can look at it and be like, oh, it's just one number. Then you But the end result is it rolls a 27, it subtracts.
Why is my camera so crappy?
And then minus the opponent's armor, which means armor is stored as a negative number for some reason. And then it also includes your like.
Oh, you see? The 4 will become here.
Really quick.
The 3 will become here, the 5 stay here.
I did the first rotate.
Yeah.
After that, the 4 will switch up, the 5 will become down, the 3 will become
I know
down.
the 100 has to come up for the last step.
Yeah.
So the 100 comes up.
Because I remember last time,
Yeah, that makes sense.
rotated.
I don't know. Put labels on them and follow the picture.
Oh,
Yeah.
okay. I'll have to figure it out how to do it at home.
I don't know. Let me see what you got.
Yeah, this is right. What I'm telling you is right. You just
Yeah.
label them first.
Yeah, at the 2.
It will be 5, 3, the 50. 4 is the 100.
Yep.
3, 4, 5.
Mhm.
After that, you have to switch the 4 up,
4 and a 3.
the 4 up, and the B will be adopted by the 3. But they don't have B. This 4 doesn't have B. It has only C.
Yeah.
Which the C will stay with the 400, and this will become down, which is mean the 100 will be there, the 50 will be down, and the 25 downer than 50, and the 150 will stay on the 100 too, like that.
Yeah, yeah.
Like that. Like that. That's really 50, 25.
100, then 150.
It looks like it should work, so.
And then above is 200.
And here will be 200.
And just print out.
And then the 300 attached to that on the right side. Yep. And we have to do the second rotation.
Second rotation.
Default right before you call.
This is now number 4, 5,
Okay.
3.
So
Mhm.
let's see if it's actually going to your switch statement at all.
Mhm.
Right?
Yep.
You can do this in GDP
And
too.
there's no B.
Just start with single.
100.
Sorry.
100.
And you have 46 switch.
The 5, 200.
And I put a new line in here, so that actually.
300. Yeah.
300, then 200 will adopt the 150 here. And then here we have
The
50,
value of command line.
and then 25. And now it's balanced.
That's what it is.
Yep.
We figured it out. Like this.
That looks good.
Oh, okay, what is my phone?
Yeah, we can put those inside the sewer system.
What is that one? Okay, I'm putting it on.
No, so.
I'll probably keep that as reference once I
Yeah,
finish
it's
it.
reference, yeah. But the easier way is just to do this steps 1, 2, 4.
Follow through, follow through.
First, you have to figure out what case you have.
Yeah.
After that, from there, you start go.
You have to install main, not a.
Take care.
Maybe you were doing it, yeah.
I always try to make files, yeah.
Okay. Yeah, because that looks like it's good.
Okay, thank you.
All right. I gotta go make copies of stuff.
Just a quick little question. I was drafting my left node right.
Okay.
In order search and search
Okay.
staffing. Kind of what they're looking for versus. That looks perfect.
What is that insert?
Oh, that's.
Oh, that's the end of the comment. Okay, good.
I was finally able to get PH2 done.
Okay.
I'll send it back to you, the drawer file to you.
Did you submit it to Canvas?
Yeah.
Okay. Go. You emailed it to me?
No, I'm going to.
Okay. Okay. Cool.
Let's see if I can get PH3 done this weekend.
Okay.
4 to 9.
Cool. Sounds good.